DHCP, the Dynamic Host Configuration Protocol, is a critical component of any network infrastructure. This will allow devices to automatically obtain IP addresses and other network parameters.
So what is DHCP server and how it works, I will explain you with the help of a diagram. Suppose you have a computer on your network and there is another computer on your network. So the communication between these two computers is possible directly also if you just connect the cable from one computer to another computer. So the communication is possible. For a computer or device on a computer network to connect to or communicate to another computer needs the address. If I say this is a computer A and if I say this is a computer B, so these both computers should be able to communicate with each other. So they will be able to communicate only if we provide them an address, which you usually see like this. And you also see the number like this, which are called the IP addresses. What is the IP address? What is class A, class B, class C, class D, class E? For example, this device has got 10.0.0.1 and this device has got 10.0.0.2. So when there is any traffic which goes from here to here, so this device knows that the address of this is 10.0.0.1 and this device also knows that the address of this device is 10.0.0.2. But if you notice here, I provided the address manually to this device. So what DHCP does is DHCP dynamically controls the IP addresses and it provides the IP addresses dynamically to the computers on the network. So this is the function of DHCP server. If I add a DHCP server over here, when devices on the network are trying to connect, so this DHCP server will provide the IP address to this. Similarly, if this device is connected here, it will provide the IP address here. The moment any device on the network is connected, it will ask every device on the network that who is the DHCP server. So DHCP server will respond back to the devices saying that I'm the DHCP server and here is your address. So this DHCP server will be responsible to provide the IP addresses dynamically to all the devices. So for example, if I bring in a new device here, this will also connect via wireless or via wire, but it will again ask every device on the network because this also works as a switch. So every device will get the message from this device that I'm connected on the network, provide me the IP address. So DHCP server will respond back with the IP address and other devices will not respond back because they are not equipped with the service. Similarly, if any new smartphone is connected, it will again through wireless, it will connect to the network and then it will send the message to all the devices on the network asking that who is the DHCP server. DHCP server will respond back with the IP address and this device will also get the IP address. Suppose there is one IP address assigned, there is 2 assigned to this, there is 3 assigned to this and there is 4 assigned to it. So if you notice here, I provided the IP addresses in the sequence. This is what happens because DHCP server will not provide the same address to the other devices. Why it does so? Because each device on the network, when it is connected, they have their own hardware address, which is called the MAC address. So MAC address is media access control address. Some people also say it machine access code, but this is media access control. So this address is provided by the manufacturer, hexadecimal 48-bit address, which will help the DHCP server to recognize the device, and this MAC address will be saved in the database of DHCP server, and DHCP server will recognize that I have already provided IP address to this particular hardware address or this particular MAC address, and when a new request comes from any new device, it will store that MAC address here and it will provide the IP address. What DHCP server also does, if there are the IP addresses already provided, for example, this has got the IP address 3. So if it disconnects for a moment and reconnects back, the DHCP server will provide the same IP address again because it will have a DHCP lease, and that lease we can assign that, okay, for how many days, for how many hours, for maybe how many months we want this particular MAC address to be stored here and provide the same IP address again dynamically whenever the new request comes. So these IP addresses are in different classes. This could be class A, class B, class C. For example, usually the IP address of the DHCP server or the gateway is 192.168.1.1 and then it starts in the same range 192.168.1.2, 1.3, 1.4 and 1.5. In that way, it gets the IP addresses. In our case, in pfSense, I have provided the IP address with the range of 192.168.240.1. So here my DHCP server, my pfSense is a DHCP server also, and the pfSense is responsible to provide the IP addresses to all these devices on the network. So I'll show you with the help of pfSense that how this is working. So in my case, this will be pfSense, and pfSense has many services, and DHCP is one of the services of the network which is available.